All right, let's talk about C programming. Today we are diving deep into two fundamental tools you'll find in C, struct and union. Now, if you just glance at the code, they look almost identical, but trust me, when it comes to how they handle memory, they are worlds apart. Let's get into it. So let's set the stage here. Imagine you're coding something up, maybe a student registration system. You've got a student's name, which is a bunch of characters, you've got their age, which is a number, and their grade, which is a decimal. Three totally different kinds of information. How in the world do you bundle all that up into one neat, tidy variable? Well, that is the exact problem that both structs and unions are here to solve. You see, C gives you this awesome power to create your very own custom data types. You're not stuck with just the basics like int, char, and double. Nope, you can actually design a blueprint that is tailor-made for the information you're working with. It's a game changer, really, and it brings us to the two main tools we're looking at today. Okay, first up, our first solution, the struct. The best way to think about a struct is to picture a toolbox. It's a big container, right? And it's designed to hold all your different tools, a hammer, a screwdriver, a wrench. Each tool gets its own little perfectly shaped compartment. They're all in the same box, but and this is key, they never, ever have to share space. And that right there, that's the magic phrase, own dedicated memory space. When you build a struct, every single thing or member that you put inside it gets its own private spot in your computer's memory. There's no fighting for room, no overlap, it's clean, it's organized, and it's super straightforward. And here is what that blueprint actually looks like in your code. We use the keyword struct, we give our new type a name. Here it's student, and then inside the curly braces, we just list out all the compartments we need. We've got a spot for the name, a spot for the age, and a spot for the grade. Simple as that. This is our template. Okay, so we've got the blueprint. Now let's actually build something with it. We declare a variable S1 using our student template, and we fill it up. We're filling our toolbox. Geek goes into the name slot, 20 goes into the age slot, and 85.5 goes into the grade slot. And here's the beautiful part. All three of those pieces of data exist at the exact same time, each safe and sound in its own little memory compartment. So you might be wondering, how big is this toolbox in memory? Well, the size of a struct is basically the sum of all its parts. So in this case, that's 50 bytes for the name, 4 for the age, and 4 for the grade. Now wait a minute, you might be doing the math in your head. 50 plus 4 plus 4, that's 58, right? So where are the extra 2 bytes coming from? That's something called padding. The compiler sometimes adds tiny empty spaces to make sure everything lines up perfectly for faster access. But the main takeaway is the struct is big enough to hold everything all at once. All right, we've got the toolbox down. Now let's look at a completely different approach. If a struct is a toolbox, a union is a multi-tool. You know, one of those cool little gadgets you keep in your pocket? It can be a knife, or it can be a screwdriver. Or it can be a pair of pliers, but it can only be one of those things at a time. You have to fold one away to use another. And this is where everything changes. A union also groups different data types together, but, and this is the whole shebang, all of its members share the exact same memory location. This is a huge deal. It means you can't have an integer and a character stored in there at the same time. You have to pick one. That single piece of memory can only hold one value at a time. Now, at first glance, the code to define a union looks, well, almost exactly the same as a struct. You just swap out the keyword struct for union. So here, we're making a data type that can hold either an integer or a double or a character. But don't let that fool you. The real magic, and maybe a little bit of danger, is in how that shared space gets used. Okay, time for a demo. Let's see how this multi-tool actually behaves. We make a union variable called data. Then we stick an integer in it. We say data.I equals 100. We print it out and we get 100. So far, so good, right? Nothing weird here. But just you wait. Now for the trick. Using that exact same variable, data, we now assign a double value to it. We say data.d equals 99.99. And poof, the integer, the 100 we just put in there, it's gone, vanished. It got completely overwritten because the double needed to use that same memory space. Only one can exist. Let's do it one more time just to make it crystal clear. We now assign the character A to the C member, and guess what? The double value is now toast, replaced by A. That's the one and only rule of the union. Only one value can survive at any given moment. So what about the size of this multi-tool? A union is clever. It only needs enough memory to hold its biggest possible member. In our data union, the int is 4 bytes and the char is 1, but the double is the heavyweight champ at 8 bytes. So the whole union only takes up 8 bytes of space. It's incredibly efficient.
Okay, so we've met our toolbox and our multi-tool. Now let's put them in the ring, side by side for a direct head-to-head comparison.
Let's just break it down. For memory, the struct gives every member its own house. The union makes them all live in one tiny studio apartment. For size, the struct's size is the sum of all its members. The union just has to be big enough for its largest member. And the most important one, values. A struct holds everything at once. A union can only hold one thing at a time. It's that simple. But, for all their differences, they're not total strangers. They're kind of like cousins. They're both user-defined types you create to group data. They both use that same dot operator to get to their members, and you can pass them to functions in exactly the same way. They just have, very different ideas about personal space.
So the big question is, why? Why even have both of these? Why would C complicate things? Well, because in programming, choosing the right tool for the job isn't just a nice saying, it's everything. And making the wrong choice here can have real consequences for how your program works.
It really boils down to this simple trade-off. You choose a struct when what you care about is data integrity, when you absolutely have to store a student's name and their age and their grade all at the same time. You need a struct, period. But if you're in a situation where memory is super tight and you know for a fact you'll only need to deal with one kind of data at a time, that's where the union shines. That's when you pick it for memory efficiency. Look, if you forget everything else from this, just remember this one image. A struct gives each piece of data its own house in the neighborhood. A union crams every piece of data into the same single-room apartment. It's crowded, and only one tenant can be home at a time. And that leaves us with one last question to chew on. When is that trade-off actually worth it? I mean, when would you ever sacrifice the safety of having separate data just to save a few lousy bytes? Well, think about programming for a tiny little computer chip inside your smart thermostat, where memory is measured in kilobytes, not gigabytes. Or think about crafting a data packet to send over a network, where every single bit counts. In those worlds where every byte is precious, the clever space-saving union isn't just a weird trick. It's an absolutely essential tool. Thanks for tuning in.